Welcome, or hopefully welcome back to the Reliability Matters podcast. For those of you who are counting, this is episode number 155. Today, I'm in Rosemont, Illinois at SMTAI, Surface Mount Technology International. I'm in the Ultra-HDI Pavilion on the trade show floor. And what are we going to talk about here in the Ultra-HDI Pavilion? Ultra-high density interconnects, of course. As the demand for smaller, faster, and more powerful devices grow, the need for innovative solutions in circuit design has never been greater. UHDIs represent a significant leap forward, allowing for more connections in a smaller space, pushing the boundaries of what's possible in electronic assemblies. But what exactly are UHDIs? Essentially, they refer to circuit boards with incredibly fine-pitch interconnects, enabling higher functionality and complexity in a much smaller form factor. This breakthrough is transforming industries like consumer electronics, aerospace, automotive, and medical devices where space, weight, and performance are critical factors. In this episode, we'll explore the advantages UHDIs bring to the table, from increased design flexibility and performance to better thermal management. We'll also discuss how UHDIs are set to impact the assembly process. With tighter tolerances and more intricate layouts, UHDI assemblies will require new approaches to assembly, inspection, and reliability testing. To better explain UHDI technology, we've put together a panel of subject matter experts. Tara Dunn, Director of Training and Education at the Surface Mount Technology Association, or SMTAI, will moderate a panel discussion with other subject matter experts. In addition to Tara, our other experts are Anay Verdaya, CEO of American Standard Circuits, Chris Shea from Shea Engineering Services, Michael Savigny, Owner and General Manager of SMTAI Americas, and Oren Manner, Op Center Core Program Business Director at Siemens Digital Industries Software. Ultra-HDI is here, and if you haven't seen it on your assembly line yet, it's coming, so stay tuned as we unpack the future of Ultra-HDI interconnects and what it means for the next generation of technology. And we'll start unpacking when I return in just a moment. Stick around, this is going to be good.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hi, I'm Tara Dunn, Director of Training and Education for SMTAI. I'm very excited to be here with this panel to discuss Ultra HDI and bring that all to you. So as we get started, I'd like to first have us go through and do a round of introductions. So Oren, could you start?
Sure, my name is Oren Manor. I'm based in Boulder, Colorado, and I lead the business development for Siemens EDA for DFM and PCB assembly.
Michael Savigny, SMTAI Americas, based in Manchester, New Hampshire, and general manager and owner of the company.
Anay Verdaya, CEO of American Standard Circuits, and we are a manufacturer of Ultra HDI printed circuit boards.
Chris Shea from Shea Engineering. I'm a consultant in design and manufacturing of circuit boards and test vehicles. And so that's what brings me to Ultra HDI, because we can fabricate them, but we still have to be able to assemble them.
Great. So as we get started today, can we maybe set the stage and give your definition of what is HDI and what is Ultra HDI in your world?
Okay, so I guess in our word is, I would say HDI is definitely something that our customers are doing and know how to do, have integrated processes, and are definitely doing the design at the DFM and the handoff for assembly. And at the moment, UHDI is kind of a dream and a concept and something we've got to enable our customers to start doing.
At SMTAI Americas, we're a third-party independent supplier of measurement services and equipment. And we collect a lot of data on machines, and the current state of where we are is interesting. And I'll share a bit more in a minute. But Ultra HDI is the future of where we're looking at design and development and such. And we're measuring the assembly process. And what will be interesting is how the OEMs step up to be able to meet the demands of UHDI.
So from a printed circuits board standpoint of view, HDI boards have been around for a long time. HDI stands for high density interconnect. And essentially those boards are manufactured via a series of sequential laminations and typically microvia lasers or some sort of controlled depth drilling associated with the via formation. And you tend to end up with some very complex via structures in the world of high-density interconnect. As we migrate from high-density interconnect to Ultra HDI, what really differentiates it is some of the feature sizes. So what we're starting to see is 25 and 50 micron features typically on what we would call Ultra HDI. We're also seeing smaller microvias, maybe down to 50 microns in diameter. So we're seeing smaller via sizes, we are seeing finer lines and spaces, and we're also seeing, a whole shift in material sets associated with the Ultra HDI region.
And to most people, Ultra HDI means board fabrication technology because it's enabling us to densify our circuits. But there's an impact on assembly because on the assembly side, we now need to put down smaller parts with more accuracy. And that's why we're getting involved in Ultra HDI from the assembly perspective early on, rather than waiting for it to come over the brick wall and surprise us all. So we're trying to get a leap on it.
Great. So just to kind of kick off our conversation, I have a question. So as Ultra HDI technology is pushing the limits of PCB fabrication, PCB design, PCB assembly, what do you think are the key design considerations that we all need to keep in mind? Because what we design for fabrication, for assembly, it's all interrelated, to your point, Chris.
Yes.
So, how do we bridge that gap? What things are important?
So I think, as you think about this, right, I think it's the whole supply chain that really needs to get involved as we get into the Ultra HDI space. So as complexities increase, especially from a manufacturing standpoint of view, at the end, from a design perspective, a lot of the designers can design anything they want to on a computer, but ultimately assembly and fabrication has to get that to reality. And in order to make sure that a design that's designed on a computer system is actually deliverable as an end product, I don't think it happens unless the entire supply chain is working on that design piece at the design phase all together, right? Get what's being designed be fabricated, and then what's being fabricated assembled. So I think the key thing in my mind is collaboration. And I think you need collaboration across the supply chain to end up with a successful product in the Ultra HDI space.
And if I can add to that, we need to understand our process capabilities and design within the process capability. You can design something, but if it can't be built, what's the point? Also, if only one person can build it or only one organization has the capability to build it, that's not a very good economical advantage. That's why we have people like Mike measuring our machines, letting us know our capability and what jobs we can accept or can't accept up front, and also design for those constraints that we know we will face in manufacturing. I start out in miniaturization. They design it and say, yeah, manufacturing, figure out a way to build it. We can't wait to figure out a way to build it. We have to build it based on what, or design it based on what we can build now.
We'll add to that. So when we look at the design in terms of specifications and measuring process and machine capabilities, we're looking at what the OEMs are capable of doing from a machine perspective. End users need to understand what the process requirements are going to be as well. And for a recent presentation I put together, we had looked at 2,000 printers across the industry, all makes, all models of SMT stencil printers, and 90% of them fail the initial specification for being able to produce a good, accurate print. At the end of that, there's still 60. So we do initial measurements and we do final measurements. We make some adjustments, and that 16% at the end is still machines that are incapable, like standard deviation issues, mechanical problems, whatever they might be. So you can't manufacture when you have big offsets, and they're just not going to be a tolerance for offsets that are significant in the process.
Yeah, so maybe I'll add to that. I mean, Chris said process capabilities. That's the positive side. We usually say process constraints. I know it's a bit of the negative side, but designers really have a much better understanding when you tell them that's the constraints. Capabilities is many times kind of philosophical. So we've got to get the designers to understand the constraints. We have to get them into the tools. We have to have the DRC updated so they're designing. It's very hard to build on the fact that the guy's going to pick up the phone and call you guys, when he's designers, because designers don't like to do that, right? They like to, live in their bubble and do whatever they want. And as you said, so we've got to get those constraints set up in their DRCs. We've got to get the DFM rules checks so they can actually know that what they're designing is, let's say, 80, 90% in guidelines. So when it does go over that brick wall you're saying, there's not a massive amount of issues, but maybe a few issues. And finally, I think we've got to get rid of these Gerbers. Because, Gerbers, maybe you could do for like a 4-layer board, but now that we're getting here, we really have to explain to the industry that there's a lot of intelligence in the CAD tools. You got to get it into an IPC 2581, ODB++. Doesn't really matter the format, but the intelligence has to be there. If you don't trust your supplier, this is never going to fly.
I'd like to add one thing, because I think one thing that we often forget about is the fact that we are now in North America are starting to talk about Ultra-HDI and have been for the last maybe 2 to 4 years. But the reality is Ultra-HDI has been going on for years over in Asia. So we're not necessarily have to reinvent everything, right? So fortunately or unfortunately, all the Ultra-HDI products gone into consumer electronics, which obviously means that the reliability requirements have not been as high or as much as what may be needed for some of the applications that we are now talking about in North America. But as we think about Ultra-HDI in the North American space, either from an assembly standpoint of view or a PCB fabrication or a design perspective, we shouldn't forget about the fact that there's lots of work that's been done and there's lots of Ultra-HDI boards that have been produced for many, many, many years.
That's a really good point. I was thinking we don't know what these design rules are. How do we put them into a tool for designers to use? But that's a very good point. Hundreds of thousands of devices have been built with Ultra-HDI, just not in North America. So how do we bridge that? Or can we bridge that?
Yeah. So one of the things that we do right now is we are getting a lot of customers today that are coming to us, talking to us about Ultra-HDI designs, and they're in various industries. So it's not industry specific. It's not just mil-aero. But a lot of cases we are telling them, okay, let's work together. We will set up what are you trying to accomplish, and based on what you're trying to accomplish and what our current capabilities are, which are constantly evolving and improving, we can set up today's constraints, right? Okay. And then, as you get to a next design, if things change, we can sit there and recalibrate. But that's one way to do it. Maybe not the most efficient way, but at least it creates that conversation and that dialogue in the supply chain and the collaboration. So I think that's one of the reasons why, we keep saying that collaboration at the design phase is so critical, and it really needs to be the whole supply chain. Yes, there's a lot of industry back knowledge, so we all need to utilize that, but then we also need to talk to each other so that we can put together something that's successfully buildable and it results in a good end product.
Mm-hmm.
And on the assembly side, we see the exact same parallel as you see in fabrication. The assembly technology is more advanced in Asia. We can't compete not only on price, but on the brain trust and the intelligence. We, in assembly side, have lost the edge over the years. There are things that can be assembled in Asia that we just don't have the technology here to do in the U.S. So we need to rebuild our assembly technology and parallel with the fabrication technology.
And I would add to that maybe that, another thing is we have to explain to the designers where they want to, add a UHDI module. It's probably not going to be the entire board, right? So we have to go and we have to understand where does it make sense to have a block which is going to be UHDI, because they're looking at very small components, because they want to fit a lot of complexity there, but maybe other parts of the board, analog parts, whatever, can remain as they are. So we have to help them do these reusable blocks where they have UHDI, it serves a purpose, it helps them in a specific area of logic that they want to reuse maybe on multiple designs, multiple projects, and this way we probably don't want to go and tell them, okay, let's do a full UHDI board, right? But we want to try to give these use cases where they can embed it and use it because it helps them, maybe not do too many layers, get the form factor in there. So that's, I think, what we have to work with the design community as well.
No, that's absolutely right. I mean, mix and match is really the key, and we preach that all the time where we're telling people, use it where you need to. You can mix regular technology and Ultra-HDI technology all together, and we've got many designs that we're working on right now that are a mix of these technologies, where there's a set of layers that are Ultra-HDI and then maybe the core is not.
If we look at the process considerations, where we are now and where we need to be, there is zero tolerance for rework. And even now, we know that when you rework parts, it affects the long-term reliability of the product and what it might be. So it has to be done right the first time. Everything has to be accurate. Everything has to be repeatable. The process specs need to match. They need to be at near or better than what the machine manufacturer can provide. And it's just, again, this will affect the reliability if you have to rework stuff. It's just not going to be possible. The small spacing, the small lines, the small components, they're very, very difficult to rework. So that you have to get it right the first time.
So, Ane, I know you've been working on the fabrication side of it for quite a while now, looking at different processes. There's a lot of different options out there. Hoping you could maybe comment on what were some of the surprising factors as you got into the fabrication process?
Yeah, so, I think, when you start out, you're thinking about the fact that, okay, you got to have processes that can deliver finer lines and finer spaces, right? So that sounds like initially it's like a photolithographic issue and some way to get the additive plating to the point that you can do it and you can form the circuit. But as you get into it, some of the things you do start to realize is, oh, I need smaller solder mask openings, right? So your solder mask openings start to shrink. Now, that's a lot more actually difficult to achieve than it was to achieve the finer lines and spaces. So that was a little bit of a surprise to us. We've also had some customers that have taken Ultra-HDI to a real limit. And what I mean by that is, typically a lot of times when we're talking about Ultra-HDI and we're talking about finer lines and spaces, you're talking about lines and spaces that maybe are, a couple of inches long at the most. But we've had people that have decided to string the entire circuit board up with 2 mil lines, 2 mil spaces, and have figured out that it's not easy to electrically test it because just the inherent resistance of those lines is so large that you got to really come up with new techniques. You also need to have a really good way to electrically test the boards when you get done. So that's obviously, especially with some of the very fine pads, you need to have electrical testers that are capable. We definitely have the AOIs that are very capable, but it's much harder to find electrical testers that are capable of the finer pitch testing.
So, and Chris, could you comment in a similar way? What are you finding when you're looking at your Ultra-HDI assembly test board? Maybe you could talk about the the test board itself and what you're expecting to see?
About 7 years ago, we were looking at the future of miniaturization, and we came up with the SMTAI test board. Last year, we looked at the future of miniaturization as 2024, and we came up with a new test board. If you can see, and Mike will put the pictures in, the pads are smaller, the spacing is tighter. We have less tolerance for any kind of misplacement or offset. It's going to be a big challenge because if you look at the older spacing, we had little room for offsets. If you have a bent nozzle or you miss a tick on the encoder, we don't have that slack anymore. So we have to tighten up the entire system. And it's not going to be easy. We may find ourselves going back to a particular machine that is the ultra-fine pitch placer or the ultra-small chip shooter and having to expand our assembly lines to accommodate with new equipment to be able to do this really fine feature stuff.
Where do you think we are in North America in terms of assembly for the miniaturized components that you have on your test board? How many, it's not mainstream, obviously.
No. And, to talk about some of the surprises, we know how we're going to print it. And we pretty much know how we're going to reflow it. Where we're looking at challenges is placement, because we have to trade off our speed and accuracy, our rework, and our inspection, because AOI and the fab world is 2D. AOI in the assembly world is 3D. And when we get things packed so tightly, we get shadowing and we can't automatically inspect. So I think that's going to be a big challenge for the AOI guys, is to get past the shadowing and handle the super high density.
I'm thinking about you with process control and optimizing processes. Yep. So much opportunity with Ultra-HDI. How do you see that going forward?
There needs to be some very big shifts in the way the OEMs are designing their machines to be able to meet the much smaller specs. If you consider the standard specification of a printer these days, it's 20 micron at 6 sigma. You're already talking about 25 micron lines and spacing. You cannot be off. So everything has to tighten up, the whole process. And for placement machines, again, the data that we have shows that 69% are failing the initial test to the OEM specification.
And that's right out of the box. That's not after wear and tear, correct?
That's right out of the box. Brand new machines. It is a mix of all conditions, but we have found that even brand new machines that have been calibrated by all the certified OEM service technicians still will fail their own OEM test, their own OEM specification, excuse me. And it takes a third-party independent, service or a product to be able to look at how that's happening, why that's happening, and bring their calibration methodology to a higher level of performance. So we know, based on all of our third-party measurements, that there needs to be a higher level of accuracy, repeatability from the OEMs.
And who's going to drive that? The OEMs aren't going to say, hey, let's invest some money and tighten up our machine capability, shall we? The customer, the user has to drive that back through the machine OEMs.
But, let me ask a question. So, in Asia, are not some of these machines already available, given the fact that Asia has been assembling some of these boards for a long time?
I can imagine they are. It's not particularly my market, but I can imagine that there are machines that are in the 15 micron range, like for accuracy specs, that probably are doing this work. And when you look at placement, the typical specification of a placement machine is 25 micron at 3 sigma. Placement machine manufacturers haven't even endeavored down the 6 sigma path to really step up their pass-fail requirements. So again, it takes a whole look at the whole supply chain, as you were mentioning.
And then it circles back to workforce development. We need the talent in the Americas to tune these machines and get them running. And that's where I also perceive a deficit between the engineering talent in Asia and the engineering talent in America. And a lot of that is our own doing because chasing lower cost, we exported all our technology. And now we've got to try to figure out how to reshore it, but we haven't trained people in this technology for a good 10, 15, 20 years. And that's why we see the huge experience gap in assembly. Half of us are retiring and half of us have under 10 years. So there's that big gap that we need to fill fast.
Yeah, I know this is a little off topic for Ultra-HDI, or maybe it's not off topic for Ultra-HDI, but it does hit a broader question. How do we bridge that gap?
Well, we need to be, in my opinion, more open about knowledge sharing with each other, not treat everything like a trade secret. If you go back to when surface mount really started booming in the 80s and 90s, we all shared information, we all published information, and now the slightest bit of information is considered a competitive advantage, so nobody wants to share it. So I think we have to open back up and start sharing again, and I think we need to embrace current media. And use more video, more YouTube, more TikTok, more multimedia, because the audience we're appealing to grew up on cell phones. So we need to embrace that media to help. And when we do, it's a much more efficient way of raising the full knowledge base of the industry because it's just so much more accessible to everyone.
Yeah, and I'd like to maybe add on to that for a second and also say that you spoke about that big, generation gap, people retiring, people are under 10 years. So on the design side, we see that a lot. We can't expect somebody just out of college that's starting to do design work to be a process expert. He doesn't even have the basic SMT knowledge. He probably hasn't seen an SMT line in his life. So to him to think now and understand how these machines work and how these printers work and what are the processes, and even to ask the right questions is not, a trivial task. The other thing that we're seeing is that this really blends in IC technology, right? IC packaging and board. And these, even in the OEMs which do both of these are completely different teams. So the OEMs really need now, and when I say OEMs, I mean the design guys. Okay, not the OEM machine makers, but the OEM design guys. They really have to take talent from the IC world, their design guys there, their board guys, and put them into kind of a joint group. Because you really need IC technology and IC know-how, IC tools, and PCB tools together. So it's not that we got that team, they do IC, they don't talk to anybody, they don't care what a PCB, and another team that doesn't care what IC is. We really have to blend these together. And if they do that, then we have a chance of really getting, these things starting to come out of the design work.
So you bring up a really good point that we need to not just educate the manufacturing engineers, but we need to educate the design engineers on the manufacturing. I hate to say back in the day when we had captive shops, you'd bring your designer down on the line for the prototype run. We'd say, don't put that fine pitch part out in the corner. It's going to be hard to build. He'd do it anyway. Then he'd see it assembled and go, hey, how come that's off center? Because you put it on the corner of the board. This is why we asked you not to put it on the corner of the board. And the next artwork spin comes out and that fine pitch is no longer on the corner of the board because he saw and he learned. So how do we take that in-person experiential learning and translate it into design talk for designers who can't go down to the production floor and see their board being built? So that's going to be a key.
So I think along the lines that what Chris and Oren were saying, I think what's important is for companies to really take an active role in educating the community, right? And what do I mean? Like all of us are in the same boat. We all have people at two ends of the spectrum with a big missing blank in the middle, right? That's the story in design, that's the story in fabrication, that's the story in assembly, that's kind of the story of the North American electronics industry in many cases. So I think companies just need to take a more active role in education, and we need to take an active role in educating the other parties, right? So we shouldn't just be focused on educating our own engineers. We're also working with the design team and inviting designers to go visit a fabrication shop. Come on by, take a look at how assembly is done. Take a look at how a board's actually manufactured. Trying to get that experiential learning to all of these different categories of people so that we're all able to function much better in our ecosystem.
Here, our question was, where are we going to get the PhDs to do this type of work and develop a test vehicle that's going to work?
So I think at the end of the day, right, today, there is monies being handed out by the U.S. government to a number of fab shops to really help develop the technology. The reality is, and you said it best, that we have a lot of that technology already sitting in Asia today. So we also have the supply base in the U.S. are the suppliers of the technology that the Asians are using in order to manufacture Ultra-HDI boards today. So I think for a U.S. company, the best possible solution, given where we are today, is to really partner with the supply base, especially from a printed circuit board standpoint of view, because they have a lot of that knowledge already. There are equipment suppliers that have a lot of knowledge already. So for us, the key is going to be partnering with those people, because the reality is we don't really need to reinvent. We need to take what's there and modify it in some way, shape, or form to improve the reliability that might be required for U.S. specific products or for mil-aero products where these applications have not been used before. I mean, Ultra-HDI is relatively new for the U.S. defense industry. Now, some of it is not, and some of it they've been getting from Japan already. So the reality is some of the customer requirements are being met today. They're just being met from not in North America. And what we're working on right now is to try to figure out ways to be able to offer something similar in North America. And we have the industry knowledge to now bank on, not where we were 20 years ago when it was brand new to the whole industry. And that's where you needed all the PhDs and all the real science was being developed at that time. Today, it's more of an application because the science already exists. It just doesn't exist very nicely in North America in a PCB shop or in an assembly shop. But the applications are being done on a daily basis. They're just not being done on this continent.
And we have PhD chemists and physicists. We don't have a very glamorous industry. We need to up the glam so people want to work in fabrication and assembly, don't we?
Yes.
You walk through a fab shop and you go, oh, wow. Can't I go do some AI or nano or other buzzword thing? So we have to really... I've been doing this 35 years and it still excites me. We have to spread that excitement at the university level. There's no class you can take in any college on surface mount assembly, and I bet there's no college classes on PCB fab. Nobody even knows what a great industry this is and how much impact we can have on all of humanity because we have no exposure at those college levels.
Agreed.
So not knowing PCB fab and PCB assembly when you were going to school, what got you excited to join the industry? How did you end up here?
A Fuji CP2. I was working on hard automation in the automotive industry, and the first time I saw a fast chip placer, I said, how many? How fast? With what tolerance? Now, we laugh today because the CP2 is, anchoring somebody's boat out on Lake Michigan, but it's that automation, that speed, that tolerance, that's what gets the mechanical engineer's juices flowing. So that's what I fell in love with. And then I ended up going into soldering more than placement because I also have a penchant for metallurgy.
Mine was a CP6, Chris.
He's 10 years younger. Mike, how would that CP2 measure up these days?
Definitely in the 1 sigma range.
How about you, Ane? How did you end up in the industry?
So I ended up in the industry. It's a pretty interesting story. So I graduated with a master's in chemical engineering and didn't want to do a standard job that chemical engineers do. I was just looking for something different. And along came a job offer from IBM to actually work on chip scale packaging. So I actually started my career in ceramic chip scale packages and then in a couple of years, just migrated into printed circuit boards.
So for Ultra HDI, looking at end use and markets, what do you think is driving that in the U.S., in North America? The need for Ultra HDI?
So I think at the end of the day, in today's world, I think the mill aerospace is one of the primary drivers, because they're utilizing it to some extent already. They're doing chip packages today already, but they're having to import it from Japan. And I think everybody's gotten really focused on making sure that we can actually produce critical defense items in North America. So I think they're probably one of the bigger drivers. But I have seen, as we've gotten into it, I've seen demand from a lot of other kinds of customers too, now that it's prevalent in the U.S. and people that are really worried about intellectual property don't necessarily want to go to Asia to get some of their items built, or they consider it critical. They're starting to come to us to talk to us about trying to build some of these products.
And so going from prototype to production to adoption of Ultra HDI as a standard technology at some point, what does that timeline look like?
I mean, in my opinion, we're probably yet 3 to 5 years away on that transition, right? I mean, while a lot of people can make some stuff and they can make it in limited quantities, I mean, there's nobody that's got real production capability today. Mm-hmm. So I would say probably yet 3 to 5 years away. I know there's a couple of people that are putting up plants as we speak, but it's going to be a while for it to be up and running and to be actually able to produce, given a lot of what's been said already today. I mean, the process controls have to be really, really tight. I mean, everything has to operate at optimal capabilities in order to be producing good boards consistently. Mm-hmm. And it's going to just take us a while to learn all of that. And, there's no pre-planning. I mean, you got to start doing and learning. Mm-hmm. And you got to fail, and you got to fail fast, and then keep moving forward.
About your time frame, 3 to 5 years, I feel like it's going to be longer. Just looking at the incremental rate of improvement changes with OEMs and their machine capabilities, it's going to have to be a significant paradigm shift to get where we need to be able to do that manufacturing with low defects or no defects, really. We have to do it right. As I mentioned, we have to do it right the first time. And now we're going to have to look at the holistic approach to quality optimization, which drives efficiencies, which reduces defect costs. And when you have that more capacity and more productivity on the lines, then your profitabilities are up. So anybody who's going to be doing this type of work is going to have to be looking at their profitability, their defect reduction initiatives, and really understanding the process.
And applying statistics to it, because data does not lie and data does not form opinions. So the more we bring in our statistical Six Sigma, Lean Sigma toolkits, the faster we'll be able to develop and move forward.
What is it going to take for us to be successful this time?
Those who don't understand history are bound to repeat it. We need to learn from our failures. A failure isn't really a failure. It's a learning opportunity if we address it properly.
Thank you guys all for all of your comments. But as a parting comment, right, we've got design, fabrication, assembly, all sitting here at the table. I know there's a common theme of collaboration, right? How do we work together? So do you have any final comments on how we can best communicate and maybe shorten the cycle to adoption and production?
Personally, I think we'll have to understand who the key players are and perhaps set up a consortium that might be able to bring everybody together to be able to look at the soup to nuts process to be able to really understand where we're going.
And I think we spoke about it before. It was, the reshoring. I think now maybe there's much more understanding that, reshoring is important. You can maybe find somebody out there that can make it a little bit cheaper. But then, again, you don't have the knowledge here. And, we saw also in the pandemic, once you start, you have much more control. if you can get in a car and drive for 5 hours and visit your fab shop, right? That's a completely different ballgame than getting on a plane and going somewhere. So I think today there's an understanding in the world that we need to have a local supply chain. There's a lot of value for it. And even if maybe there is some higher costs at the beginning, that will pay out in the future.
It's really about the designers would end up being the focal point of creating a collaboration. So they need to think about the board shop they want to collaborate, the assembly shop they want to collaborate, and then maybe even some of them may have to get in some of their collaborators in order to create kind of very good dialogue throughout the supply chain to make sure that projects are successful, especially as we're starting out in North America.
And I think the miniaturization effort is driving a convergence between IC, fab, and assembly. So back to we have to take it soup to nuts. The products themselves are converging, the arts and sciences have to converge, and the education has to converge so we can speed this up and get back on top.
Great. Well, thank you guys so much for being on our panel today. I really appreciate all of your insight and wisdom.
Thank you, Tara.
Thank you, Tara. Great job.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to the podcast to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to the Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to Mike at mikeconrad.com. Just remember that's Conrad spelled with a K. To learn more about Reliability Matters, please visit our website at reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.